Assalamualaikum warahmatullahi wabarakatuh. To Dr. Shami and Mr. Abah Muhammad Aizudin. My name is Amirul Uman bin Azwan with number matrix 63093. So in this video, I will present my final year project 2 entitled Evaluating the Effect of Feed Pressure on Salt Separation from Saline Water for Producing Fresh Water under the supervision of Professor Dr. Shahidul Islam. So in this presentation, there are 5 sections to be discussed, which are introduction, which includes research topic, problem statement, and research objective. Next is the literature review, which includes the previous research and findings. Next is the methodology section, which includes the research approach. Next is the data analysis and research findings for experiment of objective 1, 2, and 3, and the overall findings. And last part is the conclusion and recommendations, which include conclusion, recommendation, and communication. Firstly, for the introduction part, desalination is a process that removes salts from saline water, which is either seawater or brackish water, to make it clean and fresh water. Here, I got a figure showing the schematic diagram of membrane desalination. Membrane desalination operates by pumping feed saline water into the membrane, which first will go through the pre-treatment process such as chemical pre-treatment, coagulation, and softening. This pre-treatment process is to remove dust, chloride, and suspended particle. Next is through the membrane, where the salts will be removed and only then clean or fresh water can be obtained. Here it shows, this is the problem statement for my final year project. Recent statistical forecasts have shown that around half of the population of the Earth can be subjected to conditions of water stress by the year 2030, as in 2019. Here, it shows that the world is currently facing water scarcity, and it is projected to be facing water stress or insufficient amount of water for daily consumption. This is due to the rapid growth of global population, which causes demand for clean and fresh water to increase swiftly day by day, thus affecting the quantity and quality of drinking and industrial water supply. Here, I got a figure of a pie chart showing the Earth water resources. This pie chart shows that even though 72% of the Earth is covered by water, only 1% of the amount of water on the Earth is consumable. In addition, to support the Sustainable Development Goals, 6 as stated by the United Nations, which is to ensure the availability and sustainable management of water and sanitation for all. Desalination process is one of the ways to support the SDG 6. Next is the research objectives of this final year project. The first research objective is to study the effect of pressure loss on microfilter during removal of ESS from saline water. ESS here is the total suspended solid that can be found trapped in the water column. Next research objective is to estimate the effect of pressure on separation of TDS from saline water. TDS here stands for total dissolved salts. Next, research objective 3, to determine the effect of pressure on output water quantity per unit meter PSI pressure. Next is the literature review part. Here in literature review, previous research and publications on desalination is reviewed to obtain information on desalination process. The first literature study Membrane-based technologies, especially for pressure-driven membrane process, are categorized based on their driving force, where the pore size in the membrane is the key features. Ricardo Romero, 2020. Next, literature study 2. Microfiltration membranes have a wide range of pore diameters in the range of 0.1 to 20 micrometer, which allow microfiltration to be applied in many areas. ANIS 2019. Microfiltration is capable of removing micrometer-sized matter such as suspended particles, major pathogens, large bacteria, proteins, and yeast cells. ANIS 2019. Next, 5 studies on desalination process. From the source of Visha and Hariati, 2016. Total suspended solid TSS is the total amount of solid trapped and floating in the surrounding water, and the TSS movement is highly affected by water mass transfer and will settle down to the bottom of the water at some point when turbid inflows are weakened. Next, from Manipuri and Calgary 2017, it has been well established that the rate of feed flow seems to have a major effect on the efficiency of cross-flow microfiltration operations. Next, Tawalbe 2018, premade flux and rejection are determined by the feed pressure change imposed at different feed concentrations. Next is the methodology part. Here, I got a figure showing the flow chart of general experimental procedure. First, the river water is pumped into bioreactor tank. Next, the air is supplied into the tank by the air compressor. After that, we need to measure the TSS, TDS, and water flow rate. After that, the river water is passed into the biomass granular filter 1 and 2. The biomass granular filter is to remove undesirable dissolved organic carbon fractions, including biodegradable organic matter, micropollutants, and halogenated hydrocarbons. Next is through the microfilter, where microfiltration process occurs. After the microfiltration process, we need to measure the TSS, TDS, and water flow rate again. Only then the clean water or the permeate can be transferred into the water tank. Next is a figure showing the machinery setup at Unimas Laboratory. In achieving all 3 research objectives, the experiment will be conducted at Unimas Open Laboratory. Factors affecting quality and quantity of inlet flux produced, such as feed pressure and TSS. Main equipment in these experiments are microfilter, desalination membrane, pressure gauge, rotameter, water pump, and water control valve. Here, it's not only depend on the feed pressure and TSS, it also depends on the pore size of the membrane. These factors can be divided into 2, which are independent and dependent variables. Independent variables in this methodology is the feed pressure, pore size of the membrane, and the feed water flow rate. Next is the dependent variables. Dependent variables for this methodology is the permeate flux, or the clean water, the output of the experiment, because it depends on the independent variable. Next, here I got a graph indicating the expected outcome or expected results from the experiment. This graph is the relationship between feed pressure and dissolved salts removed, or the TDS removed. From this graph, it is found that as pressure is increasing, the amount of salts that is removed is also increasing. Next, data analysis and research findings. Here I got a figure showing the experiment setup for achieving research objective 1, 2, and 3. So the pore size of membrane or microfilter that will be used for this experiment is the 5 micron microfilter, 20 micron, and 10 micron, and 20 micron. Next, the feed water will flow into the microfilter by the help of the feed pump, and here is the output of the experiment or the clean water or the permit. Okay, so this is the data analysis and research findings for objective 1. This graph is the graph of TSS separation performance against feed pressure. Delta TSS here is the indicator of the effect of feed pressure on TSS separation performance. Separation performance of 5 micron, 10 micron, and 20 micron were presented in this graph. As the TSS separation performance increases with feed pressure and decreases as it reaches the optimal feed pressure at 60 psi. From the graph, it is also found that the TSS removal performance depends on both feed pressure and membrane pore size. Here, it's found that TSS removal performance of 5 micron is the highest at 97.05 compared to the other two microfilter, the 10 micron and 20 micron, because the other two microfilter is much bigger than the 5 micron, so they cannot filter TSS as efficient as the 5 micron. Next is the data analysis for research objective 2. This graph is the graph of the TDS rejection performance against feed pressure. Delta TDS is the indicator of the effect of feed pressure on TDS separation. Separation performance of 5 micron, 10 micron, and 20 micron were presented. The TDS separation performance increases with feed pressure and decreases as it reaches the optimal feed pressure of 70 psi. From this graph, it is found that the TDS rejection performance depends on both feed pressure and pore size of the membrane. The TDS removal performance of 5 micron is the highest, which is at 4.94% compared to the other two pore size of microfilter. The TDS removal performance is low for microfiltration because microfilter can only remove TDS up to 10%. Next is the data analysis based on objective 3. The delta Q is the indicator of the effect of feed pressure on output water quantity per PSI pressure. Next, production performance of 5 micron, 10 micron, and 20 micron were presented in this graph. Permit production performance decreases from 30 psi to 45 psi and increase with feed pressure starting from 50 psi to 90 psi. From this graph, it is known that the 10 and 20 microfilter has the highest per minute production at 86.32% compared to the 5 micron. This graph indicates that the bigger the microfilter pore size, the higher the quantity of per minute output. And also, okay. Next is the conclusion. TSS separation performance of 5 micron is higher compared to the other two microfilters. The smaller the pore size of the membrane, the higher the amount of TSS can be separated. TDS separation performance of 5 micron is higher compared to the other two microfilters. The smaller the pore size of the membrane, the higher the amount of TDS can be separated. Next is the permit production performance of 10 micron and 20 micron is the highest compared to the 5 micron microfilter. This statement shows that the bigger the pore size of the membrane, the bigger the quantity of water output. So the quantity of water output increases as the feed pressure increases. Next is the recommendation. The first recommendation is the desalination membranes with a pairing of microfilter and nano membranes to be used simultaneously to produce clean water, as TSS and TDS residue in the water column is unsafe for daily consumption. Second recommendation is to pinpoint the best and more accurate method of how to increase the TSS and TDS separation performance. Next is the limitation part. The first limitation is the data obtained from the experiment was not that accurate as the desalination machine is not well maintained. Next, only the water stored in the water supply tank can be accessed, as the valve connecting the river water to the water supply tank cannot be accessed. This is the progress of final year project, starting from semester 1 to semester 2. All right, I think that's all from me. Thank you very much.